You're welcome to this session. It is session 5 of Unit 6. The session is about number of double bonds in triglycerides. Let's look at the objective for the session. By the end of this session, you'll be able to determine the number of double bonds in triglycerides. Let's look at this problem. One method for determining the level of unsaturation of the triglycerides in a natural fat is by allowing the fat to react with a known excess aqueous iodine solution. A is 0.10 mol per dm cubed sodium thiosulfate. B is a solution obtained by reacting 6.8 grams of coconut oil with 500 cubic centimeters of 0.09 mol per cubic decimeters iodine solution, and the resulting mixture made up to 1 dm cube with distilled water. Okay, so before we proceed, here we expect reaction between the oil and the iodine, but there is going to be excess, and the excess would react with this. So with the relation between the thiosulfate and iodine, we'll be able to know the excess. We'll do some subtractions where we'll know the moles that was consumed, and through that we can find the or we can proceed with other calculations. Okay, so this is an instruction, but what we need very well is the equation of reaction, which has been provided here. So the thiosulfate reacting with the iodine to produce the iodide and the tetra also thionate ion. Alright, we have to find the concentration of B in mol per dm cubed, the moles of iodine that was consumed, and the moles that was left over in the 1 dm cube of B. Assuming that the unsaturation in the coconut oil is due to alkene double bonds only, calculate the number of carbon to carbon double bonds per molecule of the triglycerides in the coconut oil. The molar mass of the coconut oil has been given as 680, and the average volume of A used as 30.5. Okay, so we start with the thiosulfate by interpreting its concentration. 0.1 mol per dm cubed, meaning 1000 cubic centimeters contains 0.1. So if 1000 contains 0.1, then the 30.5 that was used contains how many moles? It contains 0.0031 moles. And this is the moles of the thiosulfate that reacted with the iodine. So we have to find the corresponding moles of the iodine from the reaction equation between the iodine and the thiosulfate ion. From this equation, 2 moles of the thiosulfate ion reacted with 1 mole of the iodine. So 2 is equal to 1. If 2 is equal to 1, then 0.0031, what we have here, is equal to what? It will be equal to 1 over 2 times 0.0031 mole. And the answer now becomes the moles of the iodine. That is what is left after the coconut had taken some away. Now, this number of moles is contained in the small volume that was used, and so we have to now move it up to 1000 cubic centimeters, or 1 dm cubed. We interpret this as, in other words, this moles that we have here is 0.00155 moles per 25 cubic centimeters. So we take it, or we make it cubic decimeters by saying that if 25 contains 0.00155, then 1000 is equal to what? If we assume 1000 is equal to x, we make x the subject. We will have this as we have here, 1000 times 0.00155 divided by 25. And that gives us 0.062 moles per cubic decimeters of the iodine. And that is the concentration that was in excess. Alright, we can do a subtraction to get the number of moles that was consumed, given that we started with 0.009 mole per decimeters cubed. So if the volume is 1000 or 1 dm cubed, then straight away we can subtract the excess from the initial, what we started with, and that gives us 0.028 moles. This moles was in excess, so this is the moles that was consumed. The excess is the 0.062. The next task was to find the moles of the iodine left in the 1 dm cube of B. It is simple. It's just by subtracting the moles that was consumed from the moles we started with, and that gives us 0.062 moles. Alright, so we know the moles that was left. The last part was to find the number of double bonds present, and here we just have to first find the moles of the coconut, so that we will divide the moles of iodine consumed by the moles of the coconut. Then we'll know the number of double bonds. In finding the moles of the coconut used, we have been given the mass, and then we know the molar mass. It was also given to be 680. So 6.80 being the mass divided by 680 gives us 0.01 moles. Now that we know the moles of the coconut, finding the number of double bonds will be simple. So, like I said, we are going to divide the moles of the iodine consumed by the moles of the coconut. Moles of iodine consumed divided by moles of the coconut, we are going to get 2.8. We can approximate this to 3. This is almost 3. So, and remember, we don't have something like 2.8 bonds. A bond can be 1, 2. It cannot be in decimals. So we run this up to 3, indicating that there are 3 of the double bonds present in the coconut. And that's the final part of the task, and where we end this session.